Okay, so this question's a very hard one. It's from question 23 of a roller, if you guys want to know. So it basically uses Snell's Law. It's application of Snell's Law in a harder format. So remember our Snell's Law formula is just this at the top. N1 sine angle of 1 is equal to N2 sine theta of 2. And we're going to use that formula in this question. So a light ray from air, which has the refractive index of 1, into a glass cube with N equals 1.5, and then into a liquid of N equals 1.33. The boundaries between the mediums are parallel. That's crucial. Calculate the magnitude in degrees of the difference between the incident angle of 30 and the refracted angle. So calculate the magnitude, just like the number, in degrees of the difference, which means subtraction, between the incident angle of 30, so that means 30, and the final refracted angle. Remember, we're talking about difference, which means subtraction, so we minus that refractive angle, and we need to find that. So I'm going to apply Snell's law here. We can see that the glass cube, right, has boundaries between the air and the liquid. So I'm going to do two Snell's laws equations right here. So I'm going to say that N1, which we can also refer to this as air, so I'm just going to write N air instead, sine angle of 1, we already know this, but I'm going to create an equation, sine angle of 1, which I'll also write as air, is equal to N of glass and sine angle of glass as well. So that's one equation at the first boundary. N of air and sine angle of air is equal to N glass sine angle of glass. Then at the second boundary, which is right here, it also states that N glass sine theta of glass is also equal to N of water sine theta of water. Okay? So that means if N of air sine theta of air is equal to N of glass sine theta of glass, and that is also equal to N water sine theta of water, it means that this and this are equal. So N of air and sine angle of air is equal to N of water sine angle of water. So I can write this as N of air sine theta of air is equal to N of water sine theta of water. And that will be the Snell's law, and we actually know some of these points already. So let's go back up here. We know that for the air, N is equal to 1, and the angle is 30. So I can write here 1 times sine 30, because that's the angle, is equal to N of water sine of theta of water, which is 1.33, that's the refractive index, times sine theta. I'm going to write R because that's the refractive thing. And now what I do is simplify, which is really simple, because all I'm going to do is, 1 times something is just itself. So I can just get rid of that 1, it's just sine 30. So all I got to do here is divide each side by 1.3. These would cancel, and that equals to sine 30 over 1.33 is equal to sine theta of R. And now to get this angle this theta by itself, I'm going to do the inverse of sine, so sine of -1 on both sides. 1. So that would cancel, leaving the refracted angle is equal to the inverse of sine 30 over 1.33, which roughly equates to 22 degrees. I'm going to round it to a whole number this time. But we're not done yet. That's the refracted angle, right? So if we go back up here, the refracted angle is roughly 22 degrees. I'm just going to round it to a whole number. But remember, the equation's asking for the difference between the incident angle of 30 and the final refracted angle, which means, remember this formula, we're just going to sub the refracted angle for 22. So 30 minus 22 is equal to 8 degrees, and that would be the difference between our incident angle and our final refracted angle. So 8 degrees is our answer.